All right, I think we are streaming. So move this down here. Yep. Okay. All right. So Peter wanted a review of this, and he is in voice chat, so he's might ask some questions. And the thing that I was wanting to look at the most was this angle, and it makes sense if you think like you have a beam and you put a big weight on it, like 100 pounds. Well, to this beam, it weighs 100 pounds. But when you put it at a 45 and then you put that weight, let me get a new color here. When you put that weight directly down, that 100 pounds, well, now you have to break it into an X, Y component. So you'll have an X component and a Y component. And so, yes, you're only putting 100 pounds on it, but because it's at an angle, some of the weight is experienced this way, some of the weight is experienced this way, and actually weighs. There's math to it, and I don't remember the math, but it probably weighs like 200 pounds. It experiences 200 pounds in the Y because this thing is at an angle. If it was 45 degrees, I think it's like about 1.6 times, so maybe 160 pounds. I don't remember the exact math to it, but it's the same thing as when you have a strap that can hold, let's say it can hold 10,000 pounds, and you've got a crane lifting it up from that strap, and you've got the weight down here. Well, in this case, you can have 10,000 pounds as long as you don't want to, if you don't mind not having any tolerance, it will hold that. But what people don't realize is that when you have to grab something big, and this is 10,000 pounds, you can't use a 5,000 pound rope for each side because the weight is not going straight down. It's going out this way and out that way. And you have to break it into that XY component. And so you really need like 8,000. It will weigh, according to the rope, 8,000 pounds, not 5,000 and 5,000. You're not splitting the load in half. And then if it tips sideways, even more is on one side versus the other. And that is why, like most of your heads, if we go to products, findings, settings, and you look at these settings, they are going to keep these at like a 70-degree angle. You're going to have a 70-degree angle because if it gets too steep, you need a lot more thickness in the metal to withstand a force that comes down right here. And you can look through any of these heads. On an oval, it gets a little steeper, but they're wanting to keep it like 45 at a minimum, and you're going to see that this is a thicker member than the side members. But yeah, so that was the thing that I was wanting to look at, was this angle here. And let's make this shaded. And right here, you've got this this dip. So this is not going to resist very well on a load that comes down here. And I think it makes sense when you think about it as, well, if I put a weight straight down, it's holding with all of its strength. But if I put it on its side and I press down here, it's going to want to bend down. Like, that makes intuitive sense. And static point analysis, I believe, is the term. If you want to go on YouTube, like, you don't have to understand the math. It's sine and cosine and a couple other things. It's not a huge deal. But looking at a couple of examples of, if that rope, let's say you're loading something on a crane, and if that rope is very long like this, versus if you load it onto a crane and that rope is very shallow like this. That shallow angle, you will need much more strength on this cable here than you do this cable here. Just like you need a much thicker beam to resist a point load out here than you do for a beam that resists a point load like 100% vertical. So Peter, does that make sense? Okay. Oh yeah. I mean, a 70 degree would be like that. You know, this is 90. So this would be like 75, 15, right? 45 is going to go straight out like this. And you have this right here that is very, very shallow. So the thing I would recommend first is making this come up like that, because you have all of this extra connective tissue down here, right? So if you're going to have something that's very flat and shallow, make it by the finger. Can I just get rid of this? Oh, it's joined together here. I'm just going to delete it. And no, it's all right. So here's the bottom of your ring shank. Like, I would move, if you're wanting, we'll talk about the head height in a second, but if it were me, I would have this come up to there so that it would be on the finger. Now, the reason people do it this way is this is much easier. It's much easier to fit in a matching band. So you have a lot of people make the head start up here, and you can do that if it goes up. But if you need to go very shallow, I would like that shallowness to be on the finger. But having it right here where it goes flat, that's kind of... I just think that's going to be very weak. So where you have all of these extra members, have it be shallow there and then come up, so that this part of it is more vertical to resist any kind of load that gets put out here on the end. If it I'm saying right now you have this angle to it, and I'm saying make it more of this angle. Right. To have it show over the stone. I mean, this is fine up here. Like, this is all good. No, here. You've got this all joined together, so let me undelete that and isolate and explode. Let's take this and join it back together. And let's take this and join it back together. And let me try and do like a quick cage edit, just to, it's not going to be pretty, but it will... it will maybe explain a little bit better what I'm thinking. See, this is uh, this is less severe than having it all localized right here as far as that dip. You're because basically what you're looking at is you would analyze these in each of the different sections, but when you analyze from here up, this is very flat. Now when you analyze it from here, this is less flat. And if this was down on the finger, like if your finger rail was here, then this is pretty shallow, but you have a lot of meat down here. So yes, it's going to experience more weight, but it's also, you have more bars connecting. It ends up being thicker and it has more strength. I mean, you can just intuitively look at this and see this is weaker than this, right? Like if you were to grab this prong with pliers and bend, where would it bend? Right here. Right. So if you can stop it from bending here by making this straighter, that's what you want to do. As far as thickness goes, I'm going to, let's see. Let's extract an ISO curve. Let me use the part that I didn't monkey with. Extract an ISO. So that's 1.2 and 1. That's, you have plenty of thickness on this. You have plenty of thickness in these bars. These are a little bit smaller, but you have more of them, so that's fine. Yeah. So you said this, the height of this was 7 and change. Okay. 7 is average. I've seen them as tall as 10. But the thing that you have to think about is when the farther this is off the finger, the amount of times they will bang it on something, those chances raise exponentially. And let me turn on my my camera here. So I've got my microphone stand here, and frame, and I can go like this very close to my microphone stand without even looking at it, and I'm not going to hit it. But the second I start adding things to my hand, like putting something taller, I lose my your body has a sense of space. You walk through a doorway, you don't bang your knuckles on the edge of the doorway. But you put something that's 7 millimeters up, every once in a while your hand is going to bang into the doorway. 10 millimeters, you're going to be doing it a lot more often because your body moves through space, and you can't really see it here, but I am like, Oh, I need to. I need to. I still do not have my ACs installed. They went to get some sheet metal, and I think they're back. So I need to run help them. But yeah, if I target 6 personally, so if you take all of this and drop it down to the finger rail, then you're going to get back. Let's see how thick this was. That is 1.2. So if you drop that down to the finger rail, you're going to get it 6.5. Oh, something weird happened there. You can do that, but as soon as you move it down closer to the finger rail, then your matching band. Right now, you can fit a matching band underneath. When you move it down to the finger rail, you're going to have to go with a contoured band because this gets blocked by your head. So it's going to have to go around. That's why everybody does it, but like there's no... Oh, I got to switch back to small cam here. There's space here. There's space here for a matching band, but when you drop it lower, this has to go to a shadow band or a contoured band to get around the head once the head is down in that space. Everybody does this. I would take it to a 6.5, but I would not. I would take it to a 6 is what I try and design for. But I do that without making this angle. I do that without dropping the angle. So I would bring the head down and then tell them they'll have to do a shadow band to go around the base of the head. That's I would personally do it that way. Okay, I've got installers, and we have not had AC. We had a week without power, and now we're on 2 weeks without. We got power back, but we're 2 weeks without air conditioning in this place, and we're in Georgia. So, okay, I hope that helped. If you have more questions, I can take another look at it later. But that was the 2 things that I really wanted to explain was head height and that angle. All right. Okay. Good luck.